So you can follow every OSHA regulation and the 70E, and these things still may not protect you. It's technically true, but there are some things you can do about it. Check this out. What up? Let's say you have an arc flash suit, 32 calories, and you were in an arc flash incident and it happened to be exactly 32 calories. The rating on those suits, the way they're created, is that in that situation you would have a 50% probability of sustaining the onset of a second-degree burn. Now, does that specifically mean you got a 50% chance of getting a second-degree burn or the onset of a second-degree burn? Not exactly. It is more specifically about the performance of the material than it is a statement on a chance that you'll get burned. But it is important to note that it is identifying the limits of that PPE and how much energy it can withstand. So you can consider it that way, that there is a 50% chance, but again, it's more about the performance than the likelihood that you'll get burned. So technically, it's perfectly acceptable to wear 32 calorie PPE when the incident energy is also 32 calories. But based on what I just said, doesn't seem really smart, right? I mean, we don't really do that with other types of PPE. You know, consider your insulated gloves or your fall arrest equipment. You can use those things at or below the rating. So if you have 1,000 volt rated gloves, you might be a little concerned using them at 900 volts or something, which, you know, I would be concerned too, but the rating on those gloves wasn't such that at 1,000 volts it fails. They have to be proven at, like, I believe it's 5,000 volts. You know, your fall arrest equipment, something rated around 250 pounds is tested and proven at multiple times more. So why the heck with arc flash PPE and arc rating is the point of breakdown the rating? It's kind of weird. That would mean that rubber insulated gloves at 1,000 volts, its rating, that's when it starts to fail. Then you would be right by not wanting to, you know, use them above 900 or not wanting to use them above 600 or something, right? So it's not the same. So why is it like that? And then what do you do about it? What should you do? One of my litmus tests is to see in construction, not just electrical safety, but construction alone, is would I put one of my own kids in that situation? And the reason I do this is because there could be something that OSHA might technically permit. And just because OSHA doesn't have a prohibition or some rule against it, doesn't make it safe. So ask myself, would I put my kids in that situation? And if the answer is no, I shouldn't be doing it. Our teams definitely shouldn't be doing it. So then what do we do? If we're not comfortable with that 50% probability, how do we manage that? Well, there's a simple concept, and all we do is we just mirror what we're doing with, you know, electric shock PPE, and we create something called Headroom. So what is Headroom? Simply put, it's the minimum capacity that you must have and the distance to the capacity that you actually have. So take arc flash. Let's say you have an incident energy of 20 calories. You must have an arc rating of 20 calories for your PPE. But if you actually showed up with a 40 calorie suit, that distance from the 20 calorie rating to the 40 calorie rating, you know, you've built in a 50% headroom, meaning you're like twice the distance from what the suit can actually have.